Hi, I hope you're all ready for one of those rare front-end talks and had a great lunch break. We're both front-end developers, but today I'm not here to talk about the latest CSS or even introduce you to the latest JavaScript framework. Instead, we're going to talk about building apps. Apps for multiple platform natively, shiny for the customers and a joy for the team who builds them. First, I want to clarify what kind of apps we're talking about today. We have a few different. Start off with games. We know you can make a lot of money out of games, but those ideas you have to save for dinner tonight. Next up, we have standalone apps, like your task manager or your running app, your text editor. They have specific demands, like they need to be available offline to really take advantage of the platform they're built on. So we're going to skip this one as well. That takes us to the kind of apps we're going to talk about today. And those are the apps that support the service at a business. Like one of those from one of the big banks here in Sweden. Those kind of apps, service-based apps, are what most companies ask for. And they have requirements like they need to be cross-platform, you need to be quick to deploy. So many teams have to be able to work on it at the same time. And we need to rapidly do changes when the business asks us to. What we're going to talk about today isn't really new, because nothing's new. It's just the old things come back again in a different way. To see what I mean, I'm going to take you through a history lesson. First, we had really big computers back then. And we had terminal-like UIs and really, really thin clients. And then the PC came. And then we had the possibility, and we needed to install every application on every computer, so we had really thick clients. And then it evolves, and we got the internet. And we had centralized servers, web browsers, and an internet connection. And what we sent to the clients was mostly plain HTML. So we were kind of back to the thin clients again. Where are we now? What do you have in your hand? You have one of those. We have the smartphones. And we have a lot of native features. And with a lot of JavaScript, Kotlin, Swift running on them, we're kind of back to really thick clients again. We have a lot of possibilities, but we also put a high demand on the team who builds them. We have to know several different languages, frameworks, and a lot of processes. I think you recognize some of the words behind me. And we have, if we want to build native apps, we have to build the domain for every platform there is. We can cheat some with frameworks like React Native or Flutter, but then we have the question if that's the best experience for the customers, and we still have the web platform, so we still need to do it twice. So if we want to have what we have today with the yummy native features, but we want to have what we had in the history with everything centralized on a server where we can share it, and we want to write the domain once. Can we do that? Is it even possible? That's what we're going to talk about today. But first, let us introduce ourselves. I'm Jessica. I'm a freelancing front-end developer living in Gothenburg. I'm a CSS nerd, and with a love of teamwork, accessibility, and nicely looking design. I'm also a snowboarder and a mother of 2 boys. And joined me today is Joakim.
Hi. Hi, everybody. Thank you, Jessica, and thank you all for coming to this talk. So I'm Joakim Kemeny. I'm also a freelancing front-end developer. I tend to work more on the architecture side of things, but I also love building apps, and especially building native apps, especially for iOS, to be honest. I love skiing. I prefer skiing over snowboarding. I also have 2 children, and I also live outside of Gothenburg. And that's pretty much all that you get to know about us right now. You can ask us later if you want to know us more. But I'm actually going to continue this talk by doing a demo. And I am going to warn you right away, because this is actually going to be quite a demo-intensive talk. There will be some elements of live coding, which means that there are all kinds of possibilities for this to go terribly wrong. But hopefully, keep your fingers crossed and everything will be fine. Hopefully, we'll see. So both Jessica and I currently work for a bank. So we thought that for this demo, a banking application would be the perfect demo. And also, I mean, let's face it, banks are usually known for being at the forefront of new cool technologies. So it kind of makes sense in that regard as well. So this particular bank is called Sneaky Cash, as it is. It's a good name for a bank, I think. And we try really, really hard to make this a really, really pleasant experience for our customers. So we have opted out of complicated authentication flows. We don't really require an extra app that you need to use. Instead, you can just go to our app or our website and press enter, and we will let you in. That's really good. So you can see that this particular bank offers credit cards and savings accounts. And if we click on one of the accounts, you get more information about some details, or maybe the latest transactions. And we can do the same thing with the savings account here. And up to the left, we also have some widget-like things, where you can see like the totals and the trends of your accounts. Now, pretty small application, but hopefully this will be enough to show you our message today and get it across to you. So let's take a look at the code. Let's see, is it big enough? Do I need to zoom it a little bit? I can zoom it a little bit. Like that. Okay, so you can see that this app is written in a monorepository. So we have all of our client applications up in our apps folder here. We have our web application is actually a normal React application at this point, but we'll change that soon. But we also have moved all of the custom components that we have from our design system. We have actually moved them into our own component library down here that we're going to use later as well. And finally, we also have a server part here, which is a small Express server, that is used to provide a backend API for our applications. For those of you who are Java developers, Express is basically just a web application framework thing. Quite nice and quite simple, so it's good. So let's start with the server side here. So let's take a look at what kind of response we get. So let's do a normal HTTP request here to the server. And you can see that we get some information back about our accounts. So we get some details about accounts, and we get the transactions of the account. So that basically is the kind of information that you need in order to create this part of the application. So let's take a look at the code that actually creates that part of the UI. So we have it here in screens. We have a savings account screen. And for those of you who have done any kind of React development, this will look pretty familiar to you. There's nothing really special here. We have a functional component, and we use a called savings account screen. And we have our own custom components like list and list section. And we populate these components with information from our savings account. And this savings account is, we pass it to our component through a prop. So there's nothing really special about this. I guess that many of you can understand this code, and it's pretty normal. There's one thing that is a little bit different with this code, though. There's something missing. Can anybody spot what it is? No. Sorry? Don't have a key. Maybe. But we also doesn't have any kind of HTML in this page. We don't have any CSS. We don't have any style attributes. We don't have any class attributes. We actually have nothing in this component that is telling us anything about how this should look. So we can argue that maybe this is not UI code at all. But what we have is like we have put together the presentation and the structure of things. The second thing to note here is that this code is written in JavaScript, or TypeScript actually. And we also say that the server part was written in Node, so that is also TypeScript. So would it be possible to take this code that is not really UI code and move it down to the server? Maybe? That's what we are going to try to find out. So let's try it. So I'm actually going to take this code, and I'm going to see if I can find the endpoint for our server right now. You can find it down here. It's conveniently named exactly the same. It's almost like we have prepared for a demo here. You can see here that this code is very, very simple. It only returns the JSON object right now. And that is the reason for why we got the result that we got back from the when we tried it earlier. But I'm actually going to take this, and I'm going to replace it with our React code. Now, this doesn't look very good. We have a lot of errors. It's hard to understand why the problem is, but I'm actually going to rename this to TSX, because that's the first step to make it work. Let's try it again. You can see that now we get a better error message. We need some kind of configuration for this to work. So let's add some configuration. So now we added some configuration for it, and let's take a look. So now you can see that we have much fewer errors in this code. But we have one error still remaining here. React refers to UMD global. And I guess if there are any React developers in here, you probably understand why that is. And you might have solved that problem in the past as well. But I'm actually going to take a step back here and just take a look at what is happening here so you can understand the rest of this talk. So let's return to our slides here. So this is the kind of code that we just moved from our React components down to the server. So this is what many people would refer to as like normal React code, I guess. But it's not really React code that's in this stage. This is just some JavaScript, or TypeScript actually, with a bit of syntactic sugar sprinkled on top of it. And that syntactic sugar is in the form of TSX. So that's just like a DSL on top of JavaScript. And to make this into React code, we actually need to compile it or transpile it in something. And when we do that, we get something like this. And you can see that there is a global React object there, and we call create element, and that will create the actual views that we are going to use here. And this is also the reason for why our code fails right now, because we haven't really imported this React element, so we can't really use it. Now, the error says that this is the old way. That kind of implies somehow that there is a new way of doing this as well. And this new way of doing things was actually introduced in React 17. And when we use this new way, then the code instead gets transpiled into something like this. Now, why is this better? The reason for why this is better, if you take a look at the code here, you can see that it actually has no references to React whatsoever in the actual code. And the only time that React is actually mentioned is up in the import statement. And this is really good for us because we can actually configure this and make this our own instead. So we're going to try that. So let's go back to our code again. Oh, now I advanced the slides a little bit earlier, but still. So let's see if we can use this, this code, the new way of doing things. So we switch to a new way of doing things like that. And the next step that we want to do is that we don't want to use React in this case. Instead, what we want to do is that we want to use our own custom JSX runtime. Now I can see that a lot of people in here are a little bit scared. Are they actually going to implement their own custom JSX runtime? That seems like a lot of work to do. Yeah, we are, and it's not that much work. So let me show you how it looks. So our runtime actually looks like this. This is our entire runtime. So you can see that we have a JSX function here, which was a requirement from that we imported earlier. It gets the tag, the name, the children, the props, and the keys, and everything like that. And there is some code in the middle here that we can skip. But the thing that we do in the end is, instead of using React and calling like create element or anything like that, we're just returning a simple JSON object instead with information. So let's see how, if we go back to our screen again, you can see that now it's much happier. So let's try this again. Did I not change it? Let's restart it. the demo, like that. Okay. Yes, yeah, this is not working. Why is it not working?
I can see that.
Maybe you can tell a joke or something in the middle.
I don't have any funny ones in hand.
Oh, that's too bad. Okay, let's switch to that should work. Okay, let's do a quick little rescue operation here, if that's okay with you. Okay. Okay, that's how it was supposed to look. I don't really know why it didn't work. I've done this presentation so many times and it worked every time, but not today, obviously. Okay, so you can see that now what we return now is that we still have some kind of JSON information that we get back from the server. But it's a little bit different in this case, because instead of just returning information about the accounts, we're actually returning information about how the accounts should be presented as well. So in this case, you can see that we actually have like a list section here, usually a list section component with props, and that props has a transaction title. And if we go up a little bit further, you can see that we have like some children up here with the data list items. So instead of just information about the accounts, we're talking about how they should be presented. Now, is this cool? Some shaking heads. I like that a lot. This is not cool at all. This is really not cool. This is just a really, really complicated way of creating an API that doesn't work in demos, so you should not use it. But what we have done here is that we have taken some JSX code and we turned it into JSON code. And then I guess it would be possible to do it the other way around as well, to take the JSON and return it back into React components. So we have done that as well. So we have our little, we do that through something that we call a component renderer. And this is a little bit more complicated. We actually going to, in the slides, we're actually going to provide you with a demo repository. We can look at the code here, but it's not that complicated. But if you want to check it out, you can do that. So you can see that this component renderer here get the component definition. This component definition is exactly this JSON that we just returned from our API. And if we go back now, what we do is to have a serialize function here, and we go down to the bottom. There are some cleanup going on. But what we do here is that we take the name of the actual component and we look it up in some kind of dictionary where we map the name of the component to the actual React component. And then we create it using that component, passing the props and the children and everything like that. So if we go back to our demo application here, you can see if we refresh it, it still works. So everything still works in this case. Nothing is broken. So is this cool? Now we have actually taken, now we've used this JSON and turned it into React again. Is this cool? A little bit cooler, I would argue. But still, I mean, this is not something that would make this talk really worth listening to, right?
No.
No.
But we started this talk by saying we're going to do multi-platform. And this is just the web. So we want to have a friend. We want to have iOS app. And we have sneaky cache, and we have the same, like you need to enter, and woo, you're in. And here you can see we have the same information, but it had some differences because it's native, so it looks right on top on iOS. Okay, now maybe we can start making some changes.
Okay, so let's do that. So I'm actually going to go into the accounts screen here and do some changes. So let's take a look here. We go down here. So here we have a section with the savings account. So I'm actually going to take this here, and let's duplicate that, and maybe let's reverse them, and let's change the title as well to reflect that, and maybe also change like the icon here as well.
Okay, if you go to the web and we refresh it, what happens? Okay, you have another list down below that's reversed, and you have that new icon. Okay? If we go to iOS app and does the refresh there, then we have the exact same. We have the new list, we have the new icon, and we've put it all from the server. Okay, this is actually pretty cool, and this is what this talk is about. And this technique is called server-driven UI. And if you look it up, you will see Facebook use it, Spotify use it, Netflix use it. And if you, those guys here, Airbnb, Lyft, and Spotify are the ones you're gonna show up most frequently if you try to Google it. They have read tons of things about it. They all have their own implementation. That's way more complicated than the one we're showing you today. But I think you're gonna can start small and still get some benefits.
Okay, so this is an overview of this technique. What we have done here is that we're taking our code from our front end and moved it down to the back end, right? But the back end already has a lot of other responsibilities as well. You're probably going to read from a database, you're probably going to connect to different data sources and fetch information, and then you have all kinds of domain logic in the back end as well. But we have often have a lot of domain logic also in the front end, but now we move them back to the back end. And that kind of means that we have all of the logic in the back end right now. So what that means is that now we can make a change. We can make a change on the back end, and it will propagate to all users at exactly the same time. And that is pretty cool. So that means you can do like toggle features on and off like that. You can do A/B testing if you want to. Or if you take a view for a specific user at a specific day when they're wearing a specific pair of shoes or something like that, you can really customize that. And it doesn't really matter what kind of platform they are using, it will still get the same result. So we take this code and then we will transform it into JSON, and then this JSON will propagate out to all of the different clients that we have. Now I need to really just explain that we have some code in these boxes. You don't really write the code in the boxes, you only write it on the server, and then you have this deserializer that we talked about earlier that would actually create this code. So only write it once. What you do need to do though is that you need to actually implement these components yourself. So you need to create a component. So for iOS, for instance, you might implement your components using SwiftUI if you want to. For Android, you might use Jetpack Compose. For the web, you might use React or Vue or whatever you like to do. You have some requirements though. You still need to implement all the components on all platforms, and you also need to name them the same thing. You need to have the same props for each on all platforms. You need to have the same children, so they need to be composable in exactly the same way. And the reason for that is we serialize it into JSON, and then we're going to deserialize it again. So you actually that needs to match, otherwise it will be pretty problematic. And you probably need to add some linting or testing to make sure that always happens. But once you do that, this is really powerful. Now, you can make these components look any way you want. So you can make your applications look as similar to each other or as different as you want. So for instance, for SwiftUI, you might use like the stock components that we used in our demo here, but you can also create your own custom design system and do it like that if you want to. For Android, you might use Material Theme if you want to. For React, you could use like Tailwind or Bootstrap, but you should obviously use custom CSS because CSS is awesome, right? But you can do anything you want. One thing to note here as well is that you can see that the backend and the React code looks exactly the same. And the reason for that is that we actually share a component library between these two. So we write the component once, and then we add all the styling and everything to it, and then we use that in React. But on the backend, we just serialize it down to JSON, which is quite nice. So if you are more of a Java developer, you might be thinking, I don't really want to use this Node stuff in the backend. So then you can probably create like a Kotlin DSL instead and share the code between Android and your web app, or your Java server. That's possible as well. But then this what we call server-driven UI using Compose-ish, and we don't want that. So Yeah, I think that is everything. Yeah. So this is awesome and everything. I think this is a really cool technique and has so many benefits. But there are some things that is a little bit more challenging with this approach, right? So we're actually going to talk about that through a demo. But there are some things that we're not going to talk about today, and that is things like, how do we handle actions? What happens when you click a button? How do you navigate between different screens? In the demo that we have here, it's really the simplest possible hack that you can have. And in the real code that we've written for our clients, this is much better implemented, but it's also way more copyrighted, so we can't really share that in our public GitHub repository. But ask us if you want to know more about that. But what we are going to talk about, we're going to take a look at some challenges, or actually just one challenge, in our demo.
Yeah, what about the performance? That's one thing you start to think about when you said, okay, everything's going to run from the server. And yeah, gonna have some more delays. But gonna show you how we handle this by making some changes. Okay, here we have some delays for our endpoints. And I just want you to really look at number 2 there, where the show account delay, it's 10 seconds. Remember that one, okay? And if we click on it, the first thing you're gonna see is a spinner. That's what we normally do, right? And then that may be enough. Many cases it's enough. And if we go in there, we have those widgets up on top. There we have skeleton loading. And as a part of the big account response, we added skeleton loading, but each of these widgets have their own endpoint. So when they're loaded, the actual response is gonna show up. And this is a much better experience for the customers. Okay, remember that 10-second delay on the details? If we click on one, was that 10 seconds? Time travels fast. Okay. No, this is actually because of preloading. You can preload every subscreen you have, or you can preload just the ones that show up on the screen before, or you can preload of what data you have around from your customer that, okay, they're always gonna click this. This is the normal flow they're gonna do. We actually played around also with preloading on hover. So it's endless possibilities. But this is important. You have to think about this upfront. And that might be a good thing, because we are lazy sometimes. So thinking about it, it's not unique for server-driven UI. And it makes the experience better for the customers.
Okay, so before we leave this demo, we're actually going to talk about one small thing. And that's not really a challenge, just a really cool thing. So you can see that we have these custom widgets up here, but this is not normally where widgets would live. So if you go on iOS, we go back to the home screen. You can see if we go in here, you can search for sneaky cache again. Let's try it. You can see that now we have our custom widgets here as well. And the reason for first of all, why this works is that we're using native technologies here. So we are actually using Swift UI. We are not using any kind of React Native or Flutter or anything like that. So we have all the possibilities that we have with native technologies. But still, this can still be driven from the server. So the widgets can be driven from the server as well in the same technique. And that is really powerful. Just one cool thing to note here about this technique. So I think we're leaving in the demo for now.
Yeah, sounds good.
Okay, so we've talked about how this works, the techniques. We've shown you demos, shown you some code, and I cannot really get over that it didn't really work, and that's really annoying. But anyway, so one thing that you might be asking yourself is, who writes this code that we have up here? So it says backend in the title there, that was just because we had these 4 boxes. But I mean, this is code that we have taken from the front end and moved into the backend. So maybe this is actually the job for the backend developers. Maybe.
Some shaking heads.
Some shaking heads. Those are probably backend developers. Great. But on the other hand, I mean, this is still like presentation code, so this could be the job of the front-end developers, and now they are nodding. I like that. Or maybe this could be where the mythical, mysterious full-stack developer comes into the picture. Maybe this is where they fit, actually. Because, just as Jessica said in the beginning, there are so many things that we as developers have on our plates. And it's a huge difference if you are a back-of-the-back-end developer who really, really loves tuning database indexes and setting up a Kubernetes cluster gives you a kick. Or if you are a front-of-the-front-end developer who likes to spend hours tweaking animations and making sure that pixels are aligned using CSS. Those are two very, very different professions, right? But one thing that we think you should always be thinking about when you're building your applications is writing the actual functionality of the application, because that is what this is all about. What we do as developers is that we are trying to make someone's dream come true, and we do that by implementing features that our customers want. And when we do that, we need to really think about these kind of topics. Not really. Those are the kinds that actually makes the functionality of our application. And we think, and the reason why we bring this up in the talk about server-driven UI is that we think that this approach makes this very clear. We can have a couple of really, really expert backend developers who are awesome at their job, or we can have a couple of expert Android, iOS, and web developers. But the majority of developers are also awesome and experts, but they're awesome and expert at creating value for our customers. So we think that this is really clear here. And also, it's much easier to scale, so you can have like one team doing one set of features, another team doing another set of features. And that's quite nice.
Okay, now we're back to where we started. We started to talk about the team. Can you show me?
Sorry.
Yeah. Every team member has his or her own personality. We have weaknesses, we have strengths. And by now you're not listening to what I'm talking about, you're just trying to figure out who am I, right? Are you the beautiful butterfly or the old wise dinosaur? But despite our differences, we want to work together with awesome features, and we want to do it fast, and we want to do it smooth, and we want to have fun at the same time, right? And one thing we need to do is speak the same language. These guys are not, as you can see. And Joakim is the only one who knows what they actually is saying. But I don't mean just talking. You can talk your team to death by just talking. You need to create a common way to talk about our work. And with server-driven UI, you're actually going to help us with that. If you take next. We're going to have the same names for all of our components. We're going to have the same names for the variables. We're going to have the same names for even the API if it's going to follow. That means a designer who wants a new view can go to almost any developer in the team and talk about it and discuss, and they're going to understand each other. And that's kind of the key here, and it's kind of like magic. Yeah, we're soon at the end of this talk, but before that, we want to give you some key takeaways that we have recognized along the way. And the first one is this. When they have all the text, all the images, all the views on the server, you can just update it and deploy it once, and it reaches all platforms at the same time. This means that you don't have to make separate builds, and you don't have to update it to different app stores and wait for the customers to update their app. So the customer don't get the Easter egg around summer when they finally, oh, I need to update. Okay? And that's one big important stuff.
The second thing is that we think that this will actually lead to better front ends. By moving our code and the main logic down to the back end, we as front-end developer or front of the front-end developers can really focus on what's making the experience the best it can be. We can focus on making sure it's accessible to all people. We can make sure that the animations are delightful. We can focus on really keeping up with everything that Google, Android, Google and Apple and all the browsers vendors are doing. So we can focus on those kind of things, and we think that will make for a better experience. And the other thing is, since we are using native technologies, we also get like the best possible experience out of the box as well. So we don't really need to try to invent those kinds of things.
Yeah, I just talked about the magic of speaking the same language. And what it actually does, it's creating trust in the team. And if you read anything about high-performance teams, one of the key ingredients is trust. You're not going to get there anyway. So when you understand each other, you're going to work better together, and it creates like a positive spiral.
Okay, so this is the end of our talk. What we have shown you today here is not really a finalized solution in any way. It's a concept. So it's not a framework. It's not a library you can download from NPM and just try to use. Instead, what you need to do is that you need to take this idea or this concept to your team, to your organization, and see how can we adapt this to fit our needs. Maybe we just have one view that is really, really complicated and is updated all the time, where we can apply it there. Or we need to have, don't have that many iOS and Android developers. We really need to use them in the best possible way. It's up to you. So you can take some inspiration from the demo repository that we are going to share, if you want to. But I'm going to emphasize it's not production code. It's just a demo, obviously. So take a look at that, or you can take a look at our websites here as well. We have some articles about this as well, both on team communication and on server-driven UI, if you want to. And finally, both Jessica and I are freelancers, so don't hesitate to reach out if you want us to help us. Help you somehow. And I think that's pretty much it.
Yeah, thank you all for listening.
So let's see, there is some time for some questions?
Yeah, time for questions. I have a mic here.
Hello.
The backend developer who shake their head.
Yeah, it sounds very interesting what you're doing. I'm wondering, I heard about something called Dino Fresh, and it's kind of a new framework for web development. And what you're doing sounds very much like the Dino Fresh with the islands and the back-end server-side rendering and stuff like that.
That sounds really interesting.
Yeah, you haven't come
No,
across
it's a new
that?
one for me.
Yeah, for us as well. When you start to look at this, you will see that there are quite a lot of frameworks for doing server-driven UI development right now, and it's very, very different what kind of approach they are taking. Some of the frameworks really focus on, you can specify everything from like which color border should have on the server side, and some are very different. The approach that we have taken here is that we have really focused our efforts around our design system. So that's how we start. So we're making sure that we can use exactly the same components on each of the platforms. And that makes for this team dynamic that we're talking about and making sure that we can really work effectively. So that's the reason for why we have done it like this. But we have looked at that framework, but that was new for us, I think.
Yeah.
Yeah, you should check it out.
Yeah, thank you. Doing it in Angular instead. Yeah. Yeah, but that is kind of a different thing. We have server-side rendering on both React and on Angular and on Svelte and everything like that. Then you're actually rendering the actual pages on the server. But what you get then is usually that you get the actual HTML and the JavaScript and everything rendered on the server. Well, the difference here is that we want to use this to create not only web applications, but also iOS apps, Android apps, Electron apps, or whatever. That's the reason for why we've done it like this. So in that case, we can't really render the HTML on the server, because then we have already said from the beginning that we are only going to support HTML or browsers in this case, and we want to have native technologies. So that's the difference.
So we're just sending a spec to the client, and the client need to understand, okay, what does this mean?
Yeah. It's a light right in the eyes that I can see. One over there.
Yeah.
I have a follow-up question for that answer. Would you ever recommend this, for example, if you only use one platform, let's say web, for example? Are there any pros to using this way of doing it if you're only using one platform, really? Or would you only recommend it if it's multi-platform?
You get more benefits if you're multi-platform, because it's kind of a complicated way to just ship things back and forth if you just have the web, I would say.
Yeah. And just as I said in the beginning as well, we started with an API, and it was not really cool to just create an API this way. And then we started with the web; it was not really that cool. And the thing, it starts to get cool when you have multiple different platforms and you can change it for all. So I would say no.
Yeah.
I think it's much better to do like some kind of remix or something that you're writing both the code on the server and the front end at the same time if you are only looking for the web.
Yeah.
Yeah.
How do you test it? Like you're writing a concept like Wixis or something. How do you test the backend that you write it?
We actually used Playwright for that, like flow tests, where you can see when it renders. And then we have, of course, unit tests for all the components in their own habits.
And one thing to note here is also that since we are using the same logic on all of the platforms, we only have to test that logic once, and that's really, really good. And the JavaScript ecosystem is really, really nice because we have so many great frameworks. If you go and do something on iOS or Android, for instance, those kind of tools are not that good. They are okay, but they are not as good as the JavaScript frameworks. So for us, it made sense to actually do all of the functional testing on the web front end, and then do all the testing on the component side on each of the platform. So that's how we do it. Yeah. Yeah, that is a very good question. So first of all, you need to actually send these binaries to Apple and Android and the Google Play Store, obviously, because the actual components that we write, they're actually going to be submitted into the binaries, and every time we change those components, we need to send those to Apple and Google. However, Apple actually has some talks about how to do it like this. So it's okay. But what I've heard from other people who have done something similar to this is that if you're doing something completely new, you should probably, like creating a completely different feature you should probably submit it as well, just to do it. But if you're changing things within those features, then it's fine. As far as I've heard and everything, well, we have talked to a couple of people who have done this as well, and since it's actually in their own videos, it should be fine as well. Yeah. If there are no further questions, then thank you all for coming.
Thank you, and don't forget to rate the app, the talk in the app for the audience.